Okay, well, welcome to modern history. Only 70 years ago, or a little bit less. Topic is data crunching in the International Geophysical Year. Quick autobiographical note, I was born during the 18-month year in question, July 1, 57 to December 31st, 58. And as a kid, I was very eagerly following the space race. I had a Gemini capsule Revell model. I thrilled to the early Apollo missions. I kind of lost interest by the later Apollo missions and was completely blasé about Skylab. But I did read a book in my public library about this time period when the scientists of the world all joined hands and sang Kumbaya. Remembered it through adulthood, and then finally came to the subject through our mutual interest in this subject. So the International Geophysical Year, you can look at it many different ways and see many different things. It was certainly a scientific success for the first time with intergovernmental financing and support. It was real science. It wasn't just make-work science. There were real discoveries, as we'll talk about in a minute, and new discoveries that could only be done not by one scientist in one laboratory, but by many, both scientists and non-scientists, working in many locations, studying the same phenomena. And it was an artifact of its time because it had to achieve this during one of the hotter periods of the Cold War. The conflicts in the Cold War were never very far behind. Most notably, everyone knows of the United States and the USSR's race to launch satellites and the secrecy associated with one side of transparency, even embarrassing transparency on the other side. But there were others. There was a zero-sum battle between Mao Zedong's People's Republic of China and Chiang Kai-shek's Republic of China. Zero-sum ultimatums hurled both ways. And at the time, you had 7 different countries claiming pizza slice-shaped wedges of the Antarctic, often in conflict with one another, especially the UK and Argentina. So the Cold War was never far away during this time of cooperation. But it was a period of hiatus in which people could take pride and credit to the discoveries that were being made across nations, particularly in the Antarctic, which I think is the first time that science and politics found a way to cooperate, and that I hope is a signal of prospects for the future. None of that has to do with this society, of course, and so what I did is I concentrated on those topics at IGY that involved data. Enormous amounts of data were being created in distributed locations by observers of all levels of sophistication, and oftentimes these were matters that had to be resolved in real time. You couldn't transmit the data back to some room-sized computer back in Bethesda or a university to get an answer days later. You needed to know in real time when this wobbly satellite was going to next cross your path, or when a speed of sound was being measured. And so enormous amounts of big data were being created and distributed over a wide range of users and locations. And it had to be calculated well enough to be able to do the job in these remote locations. And so the researchers used devices that would be readily apparent to people centuries earlier. So it's theodolites, astrolabes, nautical tables, logarithm tables, and of course, slide rules. And so today's talk will be about how big data were accumulated, harnessed, crunched, and then preserved in a way that fostered science at the time and science in the later period. Bob? So I was delighted when Jason at Harvard mentioned the 1761 and 1769 transits of Venus. As you can well imagine, it was one of the first times that observers from multiple locations, from Newfoundland to Russia, were able to measure the transit of the planet across the sun, creating precise measurements of relative distances in the solar system. And Alexander Humboldt, von Humboldt, did the same with magnetic readings in his voyages up and down north-south, one of the first north-south explorers there in that time period. This led to the first attempt at science of this type, the International Polar Year, trying to understand the Aurora Borealis. It's tragically marred by the Ellesmere disaster. About 20 US sailors lost their life in the dense ice pack up there. And big data, not really. 20 volumes wouldn't even fill up a university library shelf with all the data that were created in that first one. There was a second polar year that was ill-chosen 1932 being the depths of the Great Depression, so that limited the amount of funding for things. And you had scientists in Germany and scientists in the West collecting data, which of course were then spread asunder as a result of World War II. Data were at least separated, in many cases lost entirely, although they did make some discoveries as well. That led to post-war, the geophysicists Lloyd Berkman and Sidney Chapman having dinner with James Van Allen, eponymous name that we'll get back to, in Chevy Chase, I think, or Silver Spring, Maryland. And they said, we should do this again. And supposedly Abigail Van Buren's chocolate layer cake was the catalyst for this discussion of bringing this in. No book about IGY goes by without mentioning the chocolate cake. So they proposed it, and they had to have some actual science behind it, because this time period, 57 to 58, was a time of solar activity. Flares and sunspots were at a relative maximum, and so that produced a lot of interesting changes and variables that could be measured. It was conveniently 25 years after the polar year. It started as polar year 3, but as they expanded their ambitions, it became the International Geophysical Year. I won't bore you with the number of acronyms of scientific societies that such a thing had to be worked through, but it did finally get through ICSU, the International Council of Scientific Unions, and it was formed with a committee in the suburban front room of the fellow from Brussels, who was the general director of that session. So it began with the US and UK and Belgium as being the senior members of this committee. This is 1956. So think the Suez Crisis, think Hungary. This is the time period of heightened geopolitical uncertainty. And it's interesting that at that time, even in the depths of the Cold War, that Yugoslavia and what was then Czechoslovakia joined this effort. The Soviet Union, I think, felt a little bit caught by surprise by this action and belatedly joined. And so they, after a year or so after some of the planning had started, the USSR joined the party. Taiwan had been extended an invitation. They didn't do anything about it. They sent another invitation to Beijing, or Peking at the time, and they said, well, we'd like to join, at which point each of them said, well, why not joining if the other one joins? And so it's either I go or they go. And so no one wanted a big geopolitical battle. Taiwan had been invited first. Taiwan was involved, didn't do very much. And we lost the greater scientific involvement of the People's Republic of China, although they did experiments during this same time period. But that was the only dropout. 67 countries, pretty good list at the time, participated in this effort, involving tens of thousands of formally trained scientists, but also homemakers, children, all sorts of people were involved in the gathering of the big data. Yes?
Before you move on, you mentioned with the first polar year they helped debug the undersea cables. What were they doing?
Well, they found that, and I'll get back to this in a minute, is that in the middle of the ocean, funny things happen to Marconi's cables. There was something happening in the middle of the Atlantic Ocean. What was that? They found the discrepancies and the aberrations so that they could be corrected. But at the time, no one thought about that very much. I'll get back to those mid-ocean ridges in a minute. As far as I can tell, UNESCO, the United Nations organization, did not contribute very much money to this effort. I think it was something for $50,000 or something like that. But boy, did they hire speechwriters. They portrayed this as the greatest peaceful activity of mankind since the Renaissance. First time of the peoples of the earth studying their problems together. Grandiose ambitions, and not entirely undeserved. For people who love graphic design, I love the logo for the IGY. You'll see, obviously, first the satellite, the first artificial satellite orbiting the globe. That was one of the pieces there. You see the globe oriented towards the South Pole and presumably the Pacific Ocean, showing the focuses on the Antarctic, the undiscovered continent, as well as the depths of the ocean. And even the terminator line between light and day shows the sun. Because the other focus of this was on the impact of solar radiation and changes in the sun on the Earth. All of that crammed into a rather attractive logo. So, from a matter of graphic design, it's a great merit badge in scout terms. I can't resist talking about IGY's political and public culture aspects, the pop culture aspects of it, because it was not only a time of education, but also entertainment. You can't get much more entertainment than the funny pages. At the Harvard Museum, we saw a picture of a Pogo talking about the cyclotron. Walt Kelly was just delighted by this geophysical year. And so his swamp critters, I'm sure most people here remember the opossum, the alligator, the owl, and the cockroach that were his swamp critters who were commenting on human follies. And so they thought it was only humans that could make 18 months a year. That was their first series of jokes. The animals had great plans to shoot men to the moon, and no plan whatsoever to bring them back. And then sardonic comments about nuclear war, with the cockroach saying that with humans out of the way, their pathway to the presidency of the United States was laid full out. All this kind of gallows humor in what was called the Geophysical year from Pogo. This is the book that I read in Salinas Public Library here on the left, a children's book about the IGY, describing all the great things that were done. Middle one here is a handout at Esso and mobile gas stations. And then at the end there's the Life magazines that came out at the end of the IGY with pictures of the ocean map, with those mid-Atlantic interesting things happening. And they didn't quite know what to do with them. So copies of originals of all of these are in the back. So take a look if you want to rediscover that, or just look at the ads from Life magazine in 1959 or thereabout. As I was talking to Lou, it was a stamp collector's dream, because you had 67 countries all commemorating the same thing. And so obviously stamp collectors, being obsessive souls like ourselves, had to collect as many of them as possible. So all of the Warsaw Pact countries would have pictures of Sputnik. All the Western countries would have pictures of Explorer, the American finally successful satellite. And they would be franked at bottom of ocean, would be the location of the post office, or South Pole. And you would have to, of course, if you wanted these, we'd have to get block prints or first day covers for all of these. If you research IGY on eBay, you are inundated not with the scientific literature, but stamps. There are all these first day covers and so forth. I never wanted to get into that. But one day there was this collection that a fellow in Long Island had generated of all of his collection. Obviously some grandchild had put it up on eBay not knowing what to do with it. I bid at the minimum level, and 2 weeks later I got the material there in the back. So if you want to see a slice both of our interest as well as another collector's interest, it's a good place to go.
It's not interesting.
Exactly. It was also just a time for the creative imagination. Ever since the mid-50s, these two creative geniuses, Walt Disney and Werner von Braun, had been doing documentaries on the subject, and this accelerated during this time. You have the visions of the 1964 New York World's Fair, and what eventually became the displays at Tomorrowland, at the various Disneylands, all with the same sort of optimistic view of the future. Donald Fagen is the musician behind the group Steely Dan, and he grew up in New Jersey reading My Weekly Reader. Anybody remember My Weekly Reader? Every week it would have something breathtaking about the IGY during this time period. And so he created a song some years ago talking about what a wonderful world it will be, with a just machine that would make key decisions, programmed by fellows with compassion and vision. Imagining something like the comic book scene you see over there on the right from the gas station handouts, and the city or world of tomorrow. This was the vision of what could be that we know from the World's Fair and later. So anyway, pop culture was a big aspect of my fascination with this era. It's almost nostalgic for a time that hasn't happened yet. It's it's a vision of the future that's already passed in some ways. So it's poignant at this time in one's life. So the focus of IGY was not the one scientist working in a lab trying to work things out. It's not James Clerk Maxwell, sitting there and deriving the speed of light from the electromagnetic waves. It's synoptic observations. It's things that only can be done by everyone together. What one scientist does in one place is not science, but what hundreds of scientists do in multiple observations of the same thing is science. So the focus was on things like meteorology, things that have variable data rather than historical information. So when they prioritized what to work on, they said, well, what is it that needs lots of people all at the same time? And that was the focus of IGY. They learned from the second polar year where the Germans and the Americans had essential data needed to correlate one with the other. And so they did things in triplicate. They created world data centers in three rather morbid locations to deal with the prospect of future conflict. So one was the United States, spread across many institutions. One was Soviet Union in a couple of locations. And the third, almost as an afterthought, was scattered between Europe and Japan, with all the weather data kept in the World Meteorological Organization in Switzerland. There were all sorts of divisions dealing with the sky, with the sea, with our planet, and with solar activity. And today I'm just going to focus on the three where I found big data crunching pieces, namely the satellites, the ionosphere, and the Antarctic. October 4th, 1957. The ham radio cover there on the right side had no words on the cover. But it didn't need anything to describe what that oscilloscope was showing with these little beeps that were happening at regular intervals around the globe. On the left side, you see a piece, I think either late in Newton's life or posthumously published, in which you have this amazing thought experiment of the endlessly falling cannonball, that if you could get enough height and enough velocity, you could endlessly go around the Earth. Pretty amazing to think that that was figured out, although it took the thrust of rockets, Tsiolkovsky and Oberth and Robert Goddard to bring it into reality. But on October 4th, 1957, the shot that was heard around the world occurred as part of IGY and as part not of IGY. So at the end of World War II, the Russians got the Peenemünde launching site for the V2s, but the Americans got the scientists and shipped the Werner von Braun and his team to Alabama, of all places, where they worked for the U.S. Army on its program. Both countries were known to be active on this throughout the 1940s and 1950s. It was not news to anyone that just suddenly emerged in 1957. In 1955, there were dual reports put out about the United States program, which was fairly widely covered, and then a report about Soviet activity that was not picked up very much. But it was out there, it was publicly noted, but not in the public eye, I guess is how I would put it. Earlier that same 57, there was a notice in a public amateur radio magazine telling Russian operators or operators, basically anyone who could read the materials, to stand by at 20 megahertz and 40 megahertz for something, and to cable Sputnik with a cable address in July of 57. So anybody who was looking at this would know that something was afoot. But even the scientists did not know the timing by which the military was going to launch this. It was on an ICBM. It was a military effort. And this is one of the dilemmas in the United States that I think either produced complacency or procrastination, because there were these disputes. Eisenhower did not want space used for military purposes. And so he was very much against using a missile that had no civilian application for this. And that explains why the Navy was given priority over the Army's Redstone or the Air Force's Titan, both of which were intercontinental ballistic missiles, which had no purpose other than the one you might think. The Navy's, the Viking vessel, had at least the goal of launching Vanguard, which was going to have a goal of mapping the ocean surface, the subsurface, ostensibly scientific, really for subs, but at least it had the patina of a civilian purpose associated with it. And that's why Navy got the nod. We'll see what they did with it. Viking was a very unstable design. You've seen it going up or going down. It was only 36 inches in diameter, had no tail fins, and was 3 stages manufactured by 3 different manufacturers. It had its challenges, as we'll see. And so you have military versus civilian, but then you have the Army and the Air Force throwing pot shots at the Navy for theirs. So you can imagine the amount of energy that was spent or wasted in the United States on these kinds of issues in the late 50s. Eisenhower tried to say, there's nothing really here. I don't worry about the Sputnik 1 iota. We congratulate them and look forward to future use, thinking it would all blow over. It obviously did not blow over. Some of you in the room probably have personal recollections of this. But it attracted a great deal of attention around the world, but particularly in the United States. Were rocked from their slumbers, thinking of United States superiority. Only way the Russians do something is if they steal the atomic bomb secrets, like the Rosenbergs. Can't possibly have done something like this. So it came as an amazing shock, given all the scientific information that led up to it. Bob? Here are a couple of cartoons from the time. There's Khrushchev courting the lesser developed countries of the world, saying, I can give you a moon, unlike the Uncle Sam there bringing candy and flowers to the same developing nation. And then you see two Army generals over here on the side seeing the USSR missile going up and saying, well, thank God it wasn't the Navy. So here we see some amateurs, and back to data. There really wasn't much data from Sputnik 1. It was just a beep, maybe a little bit of adjustment for temperature. People thought it was sending some sort of secret code, and so that's presumably why the fellow has his pencil hovering there. It was just a beep, but the later ones did try to send some more data. See a high school science club here, and you can see a fellow awkwardly holding a 50 centimeter slide rule down here at an angle just for the camera. I can't believe you use one-handed fashion, but that's what he's doing there. But it became something that people around the world would listen for. As I say, it was purposely designed to travel over as much of the landmass as possible. So it orbited in ways that would catch the United States very intentionally. So the scientists had decided that these rocket transmissions should occur at 108 megahertz, safe cycles, clear of any other kind of signals, so that they could concentrate just on that. The Russians were having none of that. They put it at 20 and 40 megahertz, adjacent to shortwave radio bands that could be accessed by shortwave and amateur radio listeners. So the facilities set up by the Americans were useless, supposedly. I don't know why they couldn't change the frequency, but the main point was that everybody could hear this. On the internet, you can pick up recordings of the sound as it hit around. You could actually see what people think was Sputnik was probably the third stage of the device, a much larger piece of metal that was going across, but everyone assumed that was the red moon, as it was called. So the Americans, and then of course, only a month later, they launched a frickin' dog into space. So really, adding insult to injury. The third Sputnik was about the size of a car. So there were these enormous things compared to the little grapefruit, as it was called by Khrushchev, of the Americans. The Navy went first. The spectacular, publicly available, televised disasters was the Vanguard not going up. Army quickly stepped in with its ICBM, with its Redstone, and launched the Explorer. And the Explorer did science, because it went up there and spotted new ion layers that had not been detected before. And so James Van Allen was describing this at a press conference, and didn't have really words for it. And one of the reporters said, so you mean it's sort of like a belt? And Van Allen said, well, yeah, it's kind of like a belt. So between journalism and science, that's where we get the Van Allen belts, the inner and outer ion layers surrounding the globe. Real science. And real science could be done with those beeps. The Sputnik would pass at more or less distance or time periods for its orbits. And from slight variations of that type, people were able to derive the weight of the object. When it started to disintegrate, it changed the ionization of the layers through it which are passing. And there's a fellow who was able to detect by how much the radio signal from WWV, the time signal from Fort Collins, Colorado, got stronger as Sputnik in the third stage started to go down, and even able to conclude that it disintegrated, that it came into several pieces So a pretty remarkable piece of derivation from just signal strength. So data couldn't be sent back to the big room. I'm sure all of us have a computer at home that fills up an entire room, and we wear our white lab coats to operate. But that was the state of the art there in this time period. So you could send the data back there and get more complete answers, but it was going to take months. And what you had was a satellite crossing at 88 minutes with a slightly wobbly result, and you needed answers in real time. And so that's why we needed all of the devices that we know and cherish in this society. This is where the homemakers and kids came into the process. Something called Operation Moonwatch, which started as an atomic war civil defense movement, but was conscripted to the civilian movement. And what would happen is that individuals equipped with these reflected telescopes that would reflect down so that someone could make a drawing or a pinpoint of the location. And you'd have people designated as the satellite was approaching and as it was receding, collecting this data. And I'm not exactly sure how it worked, but they apparently filled this in almost like an optical character basis, that they would do this and then submit it so that they were able to be processed in some way. So kind of an earlier version of the oval ABCD that we would fill in for standardized tests. But this was done by homemakers and boys and girls across the United States. And there's a book on the subject of Operation Moonwatch. So this had to be done in real time. There were calculations that could be done with more variables and more calculations, but nobody had time for that. And so, as you'll see, one of the clips I have in the back there has an appendix for shortcuts. So when a desk calculator is not available, the long divisions with multiple numbers of significant digits and more variables could be swapped out for these that could be reduced to slide rule problems of sufficient accuracy. At least you'd know where to look for the satellite the next time it would pass. And so things would be reduced to a fewer number of significant digits and a fewer number of variables. So that was the close enough calculations in the Sputnik era. Here's a curious piece. This is a slide rule that only works for 136 megahertz. Normally in devices, we have frequency or wavelength as being one of the variables that you have to insert and apply for various calculations. This one's set up on the assumption that the only thing you're getting that's relevant is a frequency of this particular size. And so it reduces the slide rule problem by turning what's normally a variable into a constant. And so allows you to do the required calculations more quickly. Presumably if they ever change the frequency that something was being transmitted out, you'd throw this one away and have to get 137 megahertz slide rule. So I don't know if there are other examples in any of these applications where someone takes something that was ordinarily a variable and produces a constant to sort of simplify it, where you know that something is only coming in at in one particular piece. I'd be interested in that.
It's amazing how poorly they chose the frequency, since the 130 megahertz range is where most of the power line noise is to be found.
No kidding. Well, I think for a lot of reasons, I say they were trying to clear room. They're saying, well, maybe that's it. Maybe no fool would be so stupid as to put it there. Then that means there's no fools around. As I say, the American purpose was to clear the airwaves, to get people on the side. The Russians were saying, heck no, we're pushing communism. We want the workers of the world to be able to tune in and hear this. So two very different approaches to transparency and secrecy. People forget that within 3 years we were hovering. It was 31-7 by 1961 in terms of satellites that were launched into orbit. Nobody remembers that. All you remember is Sputnik. All you remember is Yuri Gagarin. All you remember was that they got there first, even though we got there most. The early damage was done. Huge amounts of recriminations across America as how this could happen in terms of espionage, in terms giving away our secrets, complacency, the inter-service conflicts between Army, Navy, and Air Force. School districts started doubling the amount of mathematics and science homework. As reported in one of the books I have here, it was a boy said, "It was then and there that I began to hate communism." But they wouldn't share anything. As I say, these were coming up on ICBMs, so they weren't going to disclose. They gave the name Baikonur, and the actual town of Baikonur is hundreds of kilometers away from the real location of the site. Now the site is called Baikonur, but that wasn't true at the time, so it was kind of a, like General Patton going to go to D-Day kind of subterfuge from World War II. Same sort of thing for them. But it did finally drive people to say we can't have these inter-service conflicts. We can't have this being seen as a military use of space, and that's where you get the predecessor, and then finally to NASA is shortly after the IGY. So maybe you had to go through that catharsis of all these conflicts to get to the answer of a civilian space agency. Okay, so that's issue number one, is the satellites and big data. Second is the ionosphere. Ever since Marconi launched his signals at a high frequency, it was known that he could bounce them and get further around the globe by being able to hit this ion layer. And they knew that the higher frequencies passed right by Marconi's layer. And so at the time, 1910s, 1900s, they were considered valueless. These higher frequencies, they passed through the ion layer, they were useless, let's just give them to amateurs. And so the early allocation of the bands went to the amateurs. And guess what? They found out that they could bounce the shortwave, and in fact, they could do it better at certain times and certain conditions. And so they found that up to a maximum rate, you could actually get these kinds of bounces. So something else was happening in the upper atmosphere. So and the second IPY detected some of these and knew that they were out there. But how big were they? And what were their qualities and conditions? That was a subject of IGY. So rather romantically, the Earth is described as wearing 7 veils between the 2 Van Allen belts, these 4 ion layers, and the ozone layer. So this was all mapped out. The ozone layer was well known in '57, and these were the zones. Amazingly, something I'd never heard of, but they took 3 very small hydrogen bombs and exploded them in the atmosphere above the Indian Ocean, trying to figure out what would happen. Seems like kind of a rhetorical question, why do it, why not do it? But there was a project that did that. And in each of these cases, the idea was to create an event at a moment in time and space, and then measure how it passed through these various layers. They're combination balloons and rockets, inartfully called raccoons, that were launched, and they had grenades. And the grenade was carefully defined to be something with a minimum of shrapnel and a maximum of noise. And so these raccoons would go up and would be at a defined altitude and a defined time. They would explode and create a sound. And you would have ships or other points of location at various places on Earth measure the time that it took to go from that known altitude and time to the known location and time of the receiving object, and therefore know the speed, the average speed of sound that it went there. But because there are relationships between temperature and humidity and the speed of sound, you could, if you had enough of these locations and knowing the difference in speed of sound and how much of the atmosphere is being passed through at what angles, you could derive information about the size and thickness of these ion layers. And that was done at ships and sea and various other places, and had to be done by slide rules. So here's a chart. This is kind of the close enough, good enough chart that would be used on chipboard. You can see the simplified equation over there on the right, that there's this vaguely inverse square relationship between temperature and the speed of sound. You can see that it's slightly tweaked for relative humidity. I'm sure this omits other variables that those people in the white lab coats in Bethesda could more particularly calculate. But this would at least let you know what was from the speed of sound. You would have this measured by the device, and that could give you information about the temperature and humidity of the atmosphere as it was passing through. And those were indicia, I guess, of, if you had enough data points, of the layers that it was passing through. So again, you take something that's very complicated and you reduce it to the kind of equation that can be worked on in remote locations. The third piece that I wanted to cover in more detail was the grand example of synoptic science. This was the real thing. This is the area in which one person could not create science. You needed multiple observations to create science at all. So this is a picture of Antarctica with the 7 pizza slices that I mentioned, with Argentina and Chile and even France claiming their little slices of the continent, with the UK and Argentina being the most adversary contestants. But this is a state of territorial rights claiming Antarctica in the late 1950s. So there were a dozen nations involved. There were the 7 that were involved, ones that were close to the pole, those like Norway that had the historical connection to the South Pole. And then you had 5 other parties coming. You had the US and USSR obviously involved for Cold War purposes, South Africa, because it was another country that could look south and see claims that Argentina and Chile were establishing, New Zealand, Australia, why not us? And then Japan and Belgium for reasons I do not know. But those were the dozen nations that planted Antarctic stations during this time period. There was a long battle over the peninsula leading up to South America from Antarctica. The British claimed it for waterways. Remember, Argentina was neutral in World War II until April of 1945. So felt as a matter of national security or allied security, needing to establish that route and all of the issues, including the Falklands and everything else between Britain and Argentina. Because the United States got to that committee first, remember my earlier slide, they got the South Pole. This was the first time the South Pole had been visited by humans since 1912, since Robert F. Scott got to the South Pole, found that Amundsen had already gotten there, and then made a return trip with him and his men dying on the return trip. No one had been at this place since 1912. No woman was on an entire continent. And that was, I think, the case until 1977, when Argentina shipped a pregnant woman to Argentina so that she could give birth to the first native-born citizen of Argentina. That was 1977. Emilio Palma is the kid's name. He's now, 39 years old. I don't know if he's a celebrity or what happened to him. But now Argentina is fully coeducational in terms of the locations. These were pretty grim tours of duty for these men, spending months on end in the darkness. One favorite piece I saw from a description of the living conditions in this time was alcohol was strictly forbidden and a constant problem. So I don't know if they were bringing in bottles of mouthwash or thermos bottles or stills with whatever vegetables they had there, but strictly forbidden and a constant problem. Pretty delicious description. USSR, as I say, came in late, so they didn't get the South Pole, and so they got the so-called pole of inaccessibility, which is the place on Earth that is furthest away from anything else. And so that was their claim to fame there. But they staked out these pretty much spread out around the continent. Yes.
So I have a colleague that actually managed the contracts for sending people to this day to Antarctica, and alcohol is still a serious problem down there. It's kind of sad.
Is it still prohibited?
I don't know. I don't know about you guys.
Maybe for medicinal or religious purposes. That was prohibition,
I
right?
mean, I don't know about you guys, but if my life depended on clear thinking, if I were in a jam, I would perhaps not abide quite so much. But there you go.
Yes,
Explain
Curtis.
the pole of inaccessibility again.
It's a place on the interior of the continent. I may have a picture of it.
I thought it was pie slices.
What's that?
I thought it was pie slices.
Pie slices.
How could there be an interior for one and not another?
Well, the pie slices were just pictured on a map. I mean, that's just lawyers, diplomats drawing sectors. So, for example, I think the French had an area, Amélie land, that they had discovered just on the coast of Antarctica, and then they claimed from that all the way into the pole. But there's no dotted lines, no actual physical improvements for any of those. I mean, the Argentinians had developed some shacks or whatever, but they weren't continuously occupied. As I say, they'd send babies to be born there and trying to establish claims of that type that no other country recognized.
So it was the furthest from the shore or the furthest from land? The pole.
The pole, from other stations,
Okay.
So. It was a very deadly business. I didn't see a final count, but just in reading my materials on it, I counted up at least 50 fatalities. Planes would drop. You'd have ships that would be crushed by the ice and not being able to be rescued. Tractors, bulldozers would come along. I've got a better picture over there, but you'll see that a bulldozer would just be going along and fall into a crevasse. One crevasse near an American location was 700 meters. So like 22,000 feet, pure drop. And so a bulldozer with its driver would plunge in. And so you have the absurdity of the lower photo. I don't know if you can see it, but those are two men are holding reins. They're holding reins that are attached to the throttle and the steering wheel of that bulldozer. And trying to go through the diciest territory. So sometimes these modern devices were not going any faster than Scott's dogs in 1912. We give our thanks to those who discovered just how fragile this part of the Earth is. So the real synoptic science in IGY were the traverses. And so what we have here, I think, Vostok. Here's the pole of inaccessibility, right here. So here's the Vostok station for the Soviet Union. But you would see from each of these stations, there were these linear trajectories. And what would happen is that they would send out missions on each of these straight lines to calculate the location to make sure that they had that data, and then either do seismic shoots or core samples to learn what was underneath. One of the issues was, what is Antarctica? If you took the ice away, is it a continent? Is it islands? Is it nothing? What's down there, and how far down does it go? And then what type of magnetic conditions do you have at a pole where all the lines are all coalescing as you get down to wherever I don't know where the south magnetic pole is at this time, but you have that discrepancy between that and the geographic north. So you needed all of these. You couldn't do science unless you had all of this information. No one of these was worth a damn, but all of them together were worth a damn. Sorry.
Remind us what year Antarctica was discovered.
Antarctica was discovered? I cannot do that. I mean, Cook knew the outer conditions of the Palmer Peninsula, I think, in one of his South Pacific tours, which would have been late 1700s, help me. But, I think it was known from that time, but the extent of certainly by 1912, when Amundsen and Scott were there, they were laying it out. So those are your bookends for when that would have been created. Ricky?
Oh, no, I was just thinking of readings that he said that he only saw the ice, but he assumed there was a continent under the frozen ice.
Yeah, exactly. Well, that's really the issue that was still in IGY.
That's cool.
What's underneath there?
That was cool.
Yeah. So was it a continent, or was it just a bunch of islands? Which one was it? It's got to be one or the other, right? So there's these linear expeditions. Some of them were done literally with dog sleds. In the United States, we had these snowcats, these snowmobiles for 3 or 4 men. And there's memoirs of it. So they measured the position of the sun using a theodolite, things that we saw in the museum. You get the time from Fort Collins, Colorado, as being the best measure of time that you could get, and calculated our position using a slide rule. This has to explain to modern audiences that no, pocket calculators did not exist in 1957, and certainly they didn't exist on dog sleds or snowmobiles, to better than 200 meters accuracy using a nautical almanac. So theodolites, slide rules, nautical charts. This could have been done in 1700, right? I mean, this was all the devices and tools that we had in 1957. So they did some core samples. And funny thing there in Antarctica, they picked up coal. They picked up fossilized cellulose. Now, how could that be? Back to the question about the mid-Atlantic ridges. Since 1920, Alfred Wegener, a German meteorologist, had done what all of us have done, which is fit Africa and South America in on the map and say, obviously, the continents are drifting. And it was rejected as a crackpot theory because, of course, the crust was solid and there was no mechanism, there was no force that could cause these continents to move. So it was physically impossible for there to be this continental drift, as Wegener called it. And so it was rejected out of hand. But over the course of the 20th century, some funny things were being picked up. You had freshwater reptile fossils in both South Africa and South America the same species? How does a freshwater reptile show up in two places? Why is the geology of the Appalachian Mountains in the United States the same as the Caledonian Mountains in Scotland, the Andes and this ridge in Antarctica? And now coal in Antarctica. What was going on? Bill, did you have a comment?
Remind me what WWE stands for.
It's the radio call station. WWV is the official station of the Federal
National Bureau of
Communications.
Standards or
yeah.
NIST now.
Yeah, you tune into 50. I always do it as 15 megahertz, but I think they have other.
2.55, 10, 15 megahertz, and in those days, 20.
Oh, interesting. Okay, but, thank you for that. I didn't realize that. But anyhow, you can tune it if you want to fine tune your frequency on your ham radio. You would tune into WWV and you'd know it was 15.000 megahertz, and at the time was exactly that time. So it was a very powerful radio station that did nothing but report time.
It's still broadcast. I just didn't know what WWE was. I didn't know it was a call.
Just a call sign.
Just a call sign. Curtis.
Coal beds and tree trunks, were those on the surface? Or
No, coal down deep.
Were they dug cores?
Core samples.
Oh,
yeah,
okay.
yeah. We'll get to the Keeling curve that you may be familiar with.
Just avoid the elder things city.
Say what?
I said, just avoid the elder things city, it won't end well.
Yes, exactly. Okay, so what did they find? There was more ice than expected. There was a greater supply of fresh water in the world than anyone anticipated. And they found that while East Antarctica is a continent, West Antarctica was an archipelago. So the answer to my musical question, a continent or an archipelago, next slide, Bob. It's a continent and an archipelago. So this is a fanciful drawing of Antarctica without ice. You can see one part of it is this piece with a deep rift there that, at least at the time, was called the IGY Valley, the Iggy Valley. I don't know if it's pronounced that way. But the other part is just a bunch of islands, and eventually leading up to the mountain ridge that then goes and connects into South America. Real science. This is something that no one person could have done. It took the cooperation of the world to create this level of information about our planet. Next. So there was plenty of cooperation. In these dire conditions, you had to depend on one another. There was fire was more the issue than cold. You had situations in which stations were being burned, fires of this type. And so you had those kinds of issues. A Belgian plane went down and relayed a distress signal to Australia. Australia relayed it to the Vostok station, the pole of inaccessibility, and a pilot flew, I don't know how many kilometers over nothing but white expanse to locate the Belgian survivors and somehow connect them to safety, all in the middle of the Cold War. Japan had to evacuate its station for some reason and left all their dogs behind. They came back to the station afterwards and found that 2 of the dogs had escaped and had miraculously lived. They broke out of the kennel and fed on unsuspecting penguins. And those 2 dogs became celebrities back in Tokyo when they returned. There's a book and I think even a movie about the subject of that type. John, are you getting a picture of me or?
I've got
Thank you.
Is it pointing on a particular slide?
No, just as something, anything. So they found they needed to work together, not only for safety, but also for science. And so all of this data were being collected and aggregated in real time at that point. Bill?
Speaking of working together, that last slide of the Antarctica without ice, when was that put together? When was that created?
Pretty contemporaneously. I take it from Assault on the Unknown is a book by Walter Sullivan, who was a New York Times reporter, who was covering all of this for the New York Times and wire services in real time. And the book is 1961. So it was being created at this in this real time period. So those 12 countries, Britain, Antarctica, US, USSR, all these people at each other's throats, signed the Antarctic Treaty right after IGY, agreeing that it was a continent that was to be left for non-military purposes for the common heritage of mankind, language that then showed up in the broader Outer Space Treaty 8 years later, and may be a model for future cooperation in science. So very quickly going from adversaries to at least cooperation for this purpose in the joint pursuit of science and the avoidance of military applications. Back to data. what do you do with all this stuff? All sorts of ephemeral information. We've got microfilm, paper, photograph negatives on emulsified plastic, ice cores of very poor quality, all of this stuff going to degrade over time. Punch cards set up for systems that were long ago lost, as I say, optical paper charts that couldn't be easily processed. All of the stuff was going to go very quickly. The world data centers, the distributions were a success. The triplicates arrived at these various locations. They are maintained there. They were distributed. Scientists could come in and explain what they wanted and could get the information. Fairly cumbersome at the beginning, I suppose. And it became a means of exchange of data within these communities. The early focus, of course, was East-West. You have these things in the United States and Soviet Union and Europe and Japan for a reason, namely, what would happen if one of those was inaccessible to the others, shall we say, or to anyone, shall we say. Later, the focus really became more north-south, as the data were being used for climate and other kinds of issues more than for geopolitical issues. But they serve their purpose in both directions, in both dimensions, both north-south as well as east-west. John?
I'm curious how long it took for the data centers to be substantially complete at that time, because we didn't have the internet.
Yeah, I think these had to be shipped, physically, and then someone at the receiving end had to figure out what to make sense of them. I do not know. I think perhaps the Antarctic data were somehow integrated first, because the results were being reported. But no one piece of information was worth anything. You needed all of that. So I assume it had to be some period of time had to elapse, probably well beyond the IGY before these things became terribly useful. Since then, they've all been replaced by the World Data System. I guess they needed to give a new acronym for a new system. And what is available is digitized and more easily accessible. But it's still in the same spirit of IGY. The woman in charge of the Tennessee portion of the World Data System, successor to the IGY data center, says, we don't want a situation like in the ancient world where all the books are kept in one library that goes down in flames. We don't want another library of Alexandria. What happened afterwards? The cooperation continued, international geophysical cooperation period, all sorts of other time periods here. Those mid-ocean spreading ridges showed that the Earth was not a solid crust, and that Wegener's crackpot idea that in 1957 professors were saying to their students, stay away from this stupid idea, by 1967 became, well, that's obvious. No problem there. The data were then accumulated for global warming. It's not as much action as in the IGY or in the ozone layer issues, but it's a more difficult piece to process. And this cooperation has led to peaceful exploration both in Antarctica and beyond. So we can just simply thank those who came before us for the hard work and loss of life and other travails that they went through to bring us this. Those of us who today have more computing power in our coat pocket than existed in the entire planet in 1957. So for your time and attention, thanks very much.